Alright, so the last three equations I've already gotten written up on the board. The first one we've already seen. It's the definition of theta, S over R. We can say for very, very small angles, small angle approximation type of thing, that's equal to position divided by radius. There's really nothing wrong with saying that. If we use calculus, that this idea holds true. Okay. The next term is for angular velocity. Say angular velocity is equal to linear velocity divided by radius, and that angular acceleration is linear acceleration divided by radius. Let's just really briefly in a nutshell what's going on. Now, to graphically talk about it, we are actually talking about a specific position. It turns out that if you have a rotating object, okay, and we have several objects on that, here's the center of that. So here's my two objects. And this object is spinning with a given amount of angular velocity. We're not even going to use an angular acceleration in this case. We're going to talk strictly about angular velocity. So let's say it's rotating with a given angular velocity. Then we can say that this object's velocity is going to be in the direction of the rotation, sort of. So if I were to draw that arrow straight down, it's right there. And that this velocity here is equal to, moving the r to the other side, the rotational speed times the radius. Now that means that this object has to move faster than this object, because this object has half the radial value. So this object is going to experience a velocity similar to that, while the further out of the circle you're going to get a bigger and bigger and bigger velocity. Okay? Now if I were to talk about motion later as it goes through the circle, it's down at this point, then those velocities have changed to this and to this. They're always what we refer to as tangent to the circle. Okay? So at this point the velocities are going this way, at this point the velocities are going this way. It's actually the path that object would take if all of a sudden you were to get it spinning and then just rip the thing that spins it away. So I would like to say a record player, but most of you don't know what a record player is. But imagine a big flat wheel that if you spin it, you have these two objects on there. Once you rip that object away, they would fly in that direction. That's what we mean by tangential. This is the tangential velocity. So in all fairness, these should all have t's next to those values for tangential. Okay? So that means that my theta, my angle is my position divided by radius. My angular velocity equals my tangential velocity divided by radius. My angular acceleration is my acceleration tangential divided by radius. Okay, those are the other three equations. So that is rotational motion.